Alright, so in this video, we'll be going over the chapter 9, 10 practice test. First question, graph the rational functions and label all key features. The first thing that I'm going to do is, well, this is a linear over linear case, so there's nothing to be factored, so I'm just going to find the key features right away. So I think I'm going to find the y-intercept first. It's the easiest. It's going to be 0 comma 0 over 0 minus 3 over 0 plus 1. It's going to be negative 3 over 1, negative 3. Now my x-intercept, I find it by solving the numerator equal to 0. 2x minus 3 is equal to 0, so it's going to be 3 over 2, comma 0. Or you can call it 1.5, comma 0. And then I'm going to find the vertical asymptote. You find the vertical asymptote by looking at the denominator of the function, which is x equals negative 1. Finally, the horizontal asymptote. In this case, the degree of the numerator and the denominator are same. So it means that we need to compare the leading coefficients. So it's going to be y equals 2 over 1, y equals 2. So now let's plot these points onto the graph. First of all, my y values goes from negative 3 to 2. My xy goes from negative 1 to 1. So let's just put it in the middle like this. And then let's start at asymptotes first. X equals negative 1, labeled. Y equals 2, labeled. Y-intercept, labeled. And the x-intercept, labeled. So I've labeled all the key features. Now the graph is going to look like this. Remember that the graph is curved, getting very close to the asymptotes, and also it's same thing on the other side. Let's try another question. The g of x is x minus 2 divided by x squared minus x minus 2. The first thing that I do before I find any key features is that to identify if there are any factors to be reduced. So if I rewrite this as x minus 2, if I factor x squared minus x minus 2, it becomes x minus 2 times x plus 1. So it means that I can cancel out these two terms. So it's going to be 1 over x plus 1. Now let's identify some key features. First of all, y-intercept. Very simple. It's 0, comma 1 would be the y-intercept. X-intercept. To find the x-intercept, I need to put the numerator equal to 0. Can 1 be equal to 0? No. So therefore, there's no x-intercept. And then let's find the vertical asymptote, which is x equals negative 1 once again, and the horizontal asymptote. In this case, the numerator has a degree of 0, the denominator has a degree of 1, so the bottom side is heavier, which means horizontal asymptote is guaranteed to be y equals 0. So now let's label these points and graph the function. I have my y-intercept and the y equals 0, so through the x-axis labeled. Vertical asymptote at x equals negative 1, labeled. Y-intercept at 0, comma 1, and x-intercept does not exist. So I think it's going to look something like this. So I forgot to label the y-intercept, 0, comma 1. And then other side just going like this. Now, one thing that we haven't done yet is to consider the point of discontinuity. Because we crossed out the x minus 2 factor, it means that my point of discontinuity is going to have the x coordinate of 2. Now, I need to know the y coordinate of the point of discontinuity. So I plug in 1 over 2 plus 1, so it's going to be 1 over 3. So therefore, my point of discontinuity at 2 comma 1 over 3, so that's about here. Technically, I need to erase that part. Not intended. All right, now let's move on. Find the equation of the graphs. So in order to find the equations of the graphs, we need to identify some key features of the graphs and make the equation out of it. So the first thing that I notice is that the y-intercept is at 0 comma negative 0.75. X-intercept is at negative 3 comma 0. Vertical asymptote, there's two, one at x equals negative 2 and x equals positive 2. And then finally, the horizontal asymptote seems to be at y equals 0. Now, we want to start by looking at the x-intercepts and the vertical asymptotes first. So let's do that. So I know my function is going to be, well, the x-intercept of negative 3 comma 0 tells me that the numerator has to be x plus 3. The vertical asymptote of x equals negative 2 tells me that my denominator should have x plus 2, and also x equals 2 vertical asymptote tells me that I need to have a factor x minus 2 in the denominator. Now, let's check if the y-intercepts are working as well. If you plug in x equals 0, 3 divided by 2 times negative 2, 3 divided by negative 4, so negative 3 over 4 is indeed negative 0.75, so it is complete. If the y-intercept were not matching, then I would have had to multiply this entire function by a value to fix the issue. Also, the horizontal asymptote seems to make sense as well. If you want, you can expand it to x plus 3 divided by x squared minus 4 is also a valid answer. Let's do the same thing. For this one, we have no x-intercepts, and the y-intercept was 0 comma negative 0.5. And then we have the vertical asymptote at x equals 2, and the horizontal asymptote at y equals 0 as well. So now let's plot in some points. Well, first of all, I have the x-intercept does not exist. So it tells me that my numerator is not going to be any terms, any factors, or it's going to be something like just 1. And I can always fix that 1 to be other things if I want to. And then I have my vertical asymptote of x equals 2, which tells me that I need to have a factor x minus 2 in the denominator. So now let's check the y-intercept. If you plug in x equals 0, 1 divided by negative 2, negative 1 over 2, negative 0.5, so that works as well. But now one thing that I notice is that we have a point of discontinuity at negative 1 comma negative 0.33. So that means that, I must have had a common factor of x plus 1 on the numerator and in the denominator. And it must have been reduced to find the function. So the correct function is going to be y equals x plus 1 divided by x minus x plus 1 times x minus 2. Or if you expand it, it becomes x plus 1 divided by x squared minus x minus 2. It's also another good function. All right, at this point, let's solve the question number 3a. So in order to solve rational equations, we can either represent everything as a rational function altogether, or we can just get rid of the fractions altogether first. I like the second method. So I'm going to multiply both sides by a certain number so that we can get rid of the denominators at the same time. Now, I noticed that 2x minus 6 and 3 minus x are kind of related to each other, because 2x minus 6 can be written as 2 times x minus 3, or it can be written as negative 2 times 3 minus x. So I'm going to be mindful of that. If I multiply both sides by 2x minus 6, it's going to also get rid of the right-hand side, 3 minus x denominator as well. So let's multiply both sides by 2x minus 6. So on the left-hand side, I'll just have x plus 3 equals 2x times 2x minus 6 minus x over, or minus x times negative 2, so it's going to be plus 2x. If I expand it, 4x squared minus 12x plus 2x, then it's going to be 4x squared minus 12x plus 2x minus x. It's going to be minus 11x minus 3. Now I can either factor this to solve this equation, or I can use quadratic formula. Personally, I like the quadratic formula, so let's use that. X equals negative b plus minus square root of b squared minus 4ac over 2a. So that's going to be positive 11 plus minus square root of 121 minus 4ac, that's plus 4 times 4 times 3, so that's 48. Divided by 2a, so that's 8. That's 11 plus minus square root of 169, which is 13 over 8. Which means that it's going to be either 24 over 8, which is 3, or 11 minus 13 is negative 2. Negative 2 over 8 is negative 1 over 4. So I have two answers. X equals negative 1 over 4, comma 3. Important thing about the rational equations, though, is that you need to make sure that you check your answers. What I mean by that is you need to plug in the values. Well, fast forward, if I plug in negative 1 over 4, I'm going to have no problem. If I plug in 3, however, I see some immediate problems here. If I plug in 3 as an x value, it's going to be something like that. And if I do 3 minus 3, that's equal to 0. Denominator 0 doesn't make sense. So we know that 3 does not work. So therefore, my only possible case is x equals negative 1 over 4. Let's try part B similarly as well. The first thing that I can do is I can rewrite this expression as 5x over x plus 2 times x minus 2. So it means that if I multiply both sides by x plus 2 times x minus 2, I will effectively get rid of fractions altogether. It's going to be x times x minus 2 minus 3 times x plus 2 times x minus 2 equals 5x plus x times x plus 2 times x minus 2. So it's going to be x squared minus 2x minus 3x squared plus minus 4, but then plus 12, 5x plus x squared minus 4, so minus 4x. Sorry, x cubed minus 4x. Let's collect like terms. X cubed plus 2x squared, and then plus 3x, and then minus 12. At this point, I have a cubic equation. This is a little mistake that I made for when I was making this practice test. There's no way to algebraically solve this cubic equation specifically, so I can't proceed any further. If you were to solve it, then graphically, let's say, or in the test, you wouldn't be able to use the graphing calculator, but let's assume that we are able to use it. I get one solution of x equals approximately 1.48, which definitely has no problem because I have no 1.48 terms in the denominator. Let's move on. Given f of x equals x squared minus 5x minus 6 and g of x is equal to x minus 2, sketch the graph of f of x and g of x on the same set of axes. So the first thing that we can find for f of x is that you have the y-intercept of 0, comma negative 6. And the x-intercept, I can easily factor this to be x minus 6 times x plus 1. So it's going to be positive 6, comma 0 and negative 1, comma 0. And then another thing that I know about this function is that we have a turning point, which is in the middle of the two x-intercepts. So it's going to be middle of 6 and negative 1, which is 2.5. If I plug in 2.5, negative 12.25. So if I, and then also, let's also do g of x as well. For g of x, the y-intercept is 0 comma negative 2, and the x-intercepts is 2 comma 0. So now let's put the graph on the drawing. My y value goes as low as negative 6, so I think I'm going to have my x-axis here, and let's put the y-axis around here. So first of all, y-intercept is 0 comma negative 6, labeled. X-intercepts are negative 1 comma 0, labeled. 6 comma 0, labeled. And 2.5 comma negative 12.5. Let's assume that's about here. 2.5 comma negative 12.25, labeled. So my graph is going to look like that. That's my f of x. Let's do the same thing for g of x. G of x has the y-intercept at negative 0 comma negative 2, labeled. X-intercept at 2 comma 0, labeled. So it's going to look like this. Now we need to sketch the graph of f of x over g of x. So I know that f of x is x squared minus 5x minus 6. So it's going to be h of x is equal to x squared minus 5x minus 6 divided by x minus 2. So first thing we need to do, in order to sketch the graph of the functions combined together, we just need to find the equation first, and then we need to graph it. So if I do that, let's find well, we can first rewrite this as x minus 6 and x plus 1 divided by x minus 2, just to check there's no common factors here. But now let's find some key features. The first thing is obviously the y-intercept. The y-intercept is at 0, comma, well, if you plug in 0, negative 6 divided by negative 2 is going to be positive 3. For the x-intercepts, we already know it, 6 comma 0 and negative 1 comma 0. And then the vertical asymptote is going to be x equals 2. But then the one thing that I noticed here is that I have the degree of the numerator is 2 and the degree of the denominator is 1, which means that the numerator has a higher degree, which means that we don't have horizontal asymptotes. Instead, we're going to have the oblique asymptote. How do you find the oblique asymptote? We just need to do the long division. We need to do the polynomial division of x squared minus 5x minus 6 divided by x minus 2. X goes into x squared x times. Subtract. Negative 5x minus negative 2x is negative 5x plus 2x, so it's negative 3x. And x goes into negative 3x, negative 3 times. We don't care about the remainder, but we know that the quotient x minus 3 is going to tell me the oblique asymptote is going to be y equals x minus 3. Now let's plot these points and let's plot the key features and graph the function. First of all my xy seems to be all positive. Let's go like that. Plot the key features. X equals 2 is my first vertical asymptote, labeled. Y equals x minus 3, so that's going to go through these 2 points. Y equals x minus 3, labeled. Y-intercept 0, comma 3, labeled. X-intercept 6, comma 0, and the negative 1, 0, comma 3, negative 1, comma 0, 6, comma 0, labeled. So all the key features are labeled. Now, I think it's quite easy to graph the function like this. And like that. All right, let's move on. Okay, question number 5. So at this point, we're going to deal with the composite functions. So f of x and g of x. The first thing that I know is that to find the f of g of x, I'm going to replace the g of x with the x plus 2 divided by x squared minus 4x plus 3. So I think we're going to write as x plus 2 divided by x squared minus 4x plus 3 plus 2 divided by x plus 2 divided by x squared minus 4x plus 3 minus 1. So now I'm going to reduce the fraction here. I'm going to simplify it. I think I can do that by multiplying by x squared minus 4x plus 3, both on the denominator and the numerator. That becomes x plus 2 plus 2 times x squared minus 4x plus 3, x plus 2 minus x squared minus 4x plus 3. So that's going to be x plus 2x squared minus 8x plus 6 divided by x plus 2 minus x squared plus 4x minus 3. If I collect like terms, it becomes 2x squared. Sorry, it's going to be minus 2 plus 1. My bad. Minus 2 minus 1. Sorry. But now let's collect like terms. It's going to be negative 2x squared plus 9x minus 4 divided by negative x squared plus 5x minus 1. At this point, I don't like the negative signs on the leading coefficient, so let's switch it up by multiplying by negative 1 on both numerator and the denominator. So I have my cumulative function. Now we need to sketch this. All right, let's get going. First thing is to find the y-intercept, which is easy. You plug in x equals 0, so I get 0, 4 as my y-intercept. Now let's find the x-intercept. How to find the x-intercept? We need to solve the numerator equation. 2x squared minus 9x plus 4. So let's use quadratic formula. Actually, for this one, let's try the factoring method. 2x squared minus 9x plus 4. If I factor, I think it's going to be 2x plus something times x plus something. I need to find two numbers that multiply to a positive 4, and if combined with 2x and x, it adds up to negative 9x. So I think minus 4, for this one, order does matter, right? If I plug in like that, it's going to work. 2x minus 1 times x minus 4, yeah, negative 1x plus negative 4x, negative 8x is indeed yes. Which means that x equals 1 over 2 and also 4, which tells me I have two x-intercepts, one at negative 1 over 2 comma 0 and 4 comma 0. Then let's find the vertical asymptote. To find the vertical asymptote, we need to solve the denominator equal to 0. I think I'll have to use quadratic formula in this case. So that's, what is that? X is equal to 5 plus minus square root of 25 minus 4 divided by 2. So that's 5 plus minus square root of 21 over 2. That's a weird number, so let's use calculator. 5 plus square root of 21 divided by 2 is going to be 4.79 approximately. And if I do minus square root of 21, it's going to be 0.209 approximately. So I know that my vertical asymptotes are at x equals 4.79 and x equals 0.209. So I have two vertical asymptotes. Finally, I have the horizontal asymptote. The degrees are same, 2 and 2, so it's going to be y equals 2 over 1, leading coefficients. So y equals 2 is my horizontal asymptote. Now let's graph the rest of the function. So what do I have? I have my x-intercepts at negative 1 over 2 and 4. Both vertical asymptotes are positive. So I think I can go like this, this. So let's draw the key features. The first thing is the y-intercept, 0, 4, labeled. X-intercept, negative 1 over 2, 0, labeled. And 4, 0, labeled. Vertical asymptotes, x equals 0.209, so that's very close to the y-axis labeled x equals 4.79, labeled, and y equals 2 as my horizontal asymptote, labeled. So I think I can try to sketch the graph of this roughly. Well, the first thing that I know, sorry, x-intercept was positive 1 over 2, my bad. No, that was kind of weird. That looks better. So now the one obvious part is that the 0, comma 4, the top left-hand side of the graph, kind of looks like that, already very close to the vertical asymptotes right there. And then in the middle of the two functions, it seems like both points are below the y equals 2. So I think the graph will look something like that. I wish we were able to find the turning point, but we can't do that without calculus. And the final part, I don't know what the graph will look like when the x is greater than 5. So why don't we quickly find that out? So to evaluate, y equals 2, 5 squared minus 9 times 5 plus 4 divided by 5 squared minus 5 times 5 plus 1. Well, it's going to be 50 minus 45 plus 4 divided by 25 minus 25 plus 1. So what is that? 5 plus 4, 9 over 9 over 1. So I think it's going to be positive 9. So that's like, what? It's like here. So that's definitely over. So my graph is going to look like that. So there's my graph of the h of x. No, the f of g of x. All right, thank you for tuning in, and I'll see you in other videos.